So, like I said, this is the last section. Yesterday what we did is we looked at two events that depend on what the first event is. So I did an example where I had all these items in a cup. I've got 3 markers and a highlighter. And I want to know, what is the probability that I pick out 2 markers? So first, what's the probability that I'll pick out 1 marker first? 3 out of 4, right? 75%. Now that I've taken out this marker, what's the new probability of picking out a marker? 2 out of 3. I've taken a marker out, so there's 1 less marker and there's 1 less total. Nope, that's 66%. Yeah. So you'll notice that my second probability, now it's 2 out of 3, but let's suppose my first object that I pick is the highlighter. What's the probability of picking a marker now? Yeah, 100%, 3 out of 3. So my second probability depends on the first. And that was the big thing yesterday, was showing when does it depend on the first outcome. So you can watch that video from yesterday. We are going to look at the same thing, but kind of mixed. When does it depend on the other, and when does it not? And there's going to be some key phrases in here for you to realize when your second probability changes or not. So yesterday we said that they are dependent. The second probability depends on the first. Today we are going to have independent. So if we were to look at what would be 2 independent events. So we can look at test scores. So let's say I've got 2 students who are taking a test. Let's say the first person gets, we want to know what's the probability that these 2 students will get 100%. Or let's go 86. So does the second person's probability depend on the first? So you're right. So if we said, okay, so let's say Kenzie and Yusuf are taking a test. So if Kenzie takes a test and we say there's a 70% that she'll get an A, will Yusuf's test depend on what Kenzie gets on her test? Only if he's cheating off of her. But let's say he's not. We're going to assume he's an honest boy. So his probability, no you're not. So his probability, so your probability does not depend on Kenzie's, which means these events are independent. Now let's suppose we have someone in our class who would, suppose they would copy off of someone else's homework. That would never happen in my class whatsoever, but let's assume it does. So if I've got person A who does the work and person B who copies off of person A, does person B, does their probability of finishing the homework depend on person A? Yes. So if person A does their homework, person B will. If person A does not, person B does not. So that would be dependent. Independent, they do not depend on each other. Dependent, they do. So let's look at these 2 situations. So let's say I pick a card from a deck of 52 cards. The card is a heart, and then without putting the card back, another card is picked out. So are these 2 things dependent or independent? Does the second card depend on the first card?
Yes. Yes.
So it's the same thing with the markers, right? If I take a marker out and I do not put it back, the second probability changes. I'm just trying to find my set of notes here. So in this case, let's do it case by case. So let's look at the first card. What's the probability that the first card is going to be a heart?
Sorry?
What's the probability that the first card here is going to be a heart? Yeah. So,
13 over 52.
yeah, I've got 13 hearts total. The probability is out of 52. So this is the probability of the first card being a heart. What is now going to be the probability of the second card being a heart if I take one of these cards out and I do not put it back?
12 and 51.
Yeah, so I've got 12 hearts left, and there's 51 cards left. So if you multiply these two things together, you'll get a probability of 5.88%.
I have a question.
Yes, what's your question?
In 12 over 51, do we take out one card from both of them or only from one?
So we take out one card from both, because remember the top part is how many hearts are there? So I've taken a heart out. The bottom is how many cards total are there to pick from? So because we've taken out a card already, there's one less card. Yeah, so same thing. When we talked about our markers here, now there's out of 4, now it's out of 3. So when you take one out, you take one out from the positives and from the total. So situation 1 here, this one, they are dependent. Let's look at the second one. So 52 cards, I pick a heart, and now the card is put back, and we pick another card. Are these two going to be independent or dependent? Independent. I've put the card back. So that's like saying pick one of the markers, put it back, and try again. So my probability for this, the first card is going to be 13 out of 52. Because what's the number of hearts over the total? If I put the card back, the second probability does not change.
Don't you take one and then put the back of the thing another one?
Mm-hmm.
So isn't it supposed to be 12 and 51?
No, because I put the card back.
Oh, so you didn't draw it again.
Yeah, so it's like this. If we take our cup analogy. So what's the probability of picking a marker? 75%. I've picked it out, great. Now I put it back. What's the probability that the second is now going to be a marker again? It's the exact same thing. No. So that's the difference. If I put it back, probabilities stay the same. If I take it out and do not put it back, then they'll change. So you'll have to read the question carefully to figure this one out. So situation 1 here, this one we said is dependent. So the first event depends on the second. I misspelled that. It should be an E. And the second one is independent. They do not depend on each other.
How do I know?
If your second probability changes, depending on what the first outcome is. Mm-hmm.
This is how I do with mine.
Okay.
Has nothing to do with English. Dependent, anti-radical, dependent, B-E-N.
With an A?
Yeah, there's 2 words.
Yeah. So dependent,
Like, what's the difference?
That's,
Like, Canadian American,
I don't think,
like other and other?
no, I don't think it's that. I think a dependent with an A is like a person who is dependent upon someone else, where I think dependent refers to more than just a person. But I'd have to look that up. Because I'm not. It is. You're asking a math teacher an English question. Although I should know. Well, I should. Just like you should know fully fosa because you're Egyptian, right? Although I know that's more like comparing to, I should know Old English. So I get there's a slight difference in our comparison. Exactly. Well, the thing is because Arabic is such a vocal language and it's more a spoken thing, there's so many different dialects that you have that it's like, it's hard to have it all as a set written.
For example, we have words here that in other Arab countries are different.
Mm-hmm.
So, like, what here, makwa,
Mm-hmm.
is like an iron, okay? In Kuwait, means bottle. Yeah.
That can make for an interesting conversation.
Yeah, so in Kuwait, we call it like, it's different.
Mm-hmm.
I don't know why, I don't get it.
Well, think about this. Because your spoken language is so dependent on your location, right? It's very much, it's a verbal language less than it is a written language. Because you're here and they're over there. So simply by being distanced from them, it's different. But the convenient thing for you guys coming from Egypt is that at least the language here is more internationally recognized by other Arabic-speaking countries because most of the television is done in Amaya. So other people can at least understand you because of most of the TV series are based on that, whereas you might not understand everyone else.
Egypt is mother of the world.
Everything originated from here? So, if we are to look at independent events, today's lesson is really just a repainting of what you've seen before. Just using some different terms. So if two events are individual, the probability of both happening will look like this. Probability of A and B is just probability of A times probability of B. This is what we did up above.
Chapter 4, chapter 3 is the same as chapter 4. And chapter 4 is the same as chapter 4.
Yep. This is why I said it's really important to pay attention on the other two chapters. So this is independent, and I will put down here a little note. So remember, for dependent, dependent events. So this is what I showed yesterday. For dependent events, the probability of A and B is equal to probability of A times, and then we have a conditional probability. So this is probability of B given that A has occurred. So I'll rewrite it down here so you can see this. So this is probability Yep. Any questions with this? I can give this formula to you. You do not have to use it. When I teach this, because I know equations aren't everyone's favorite thing in foundations of math. So I more teach how to do it logically from the question, but this is if you prefer equations. Like I showed you in the question above, here I did not use equations. I'll get back. So I didn't use an equation for this. I just said, what's this probability? Take one of those out. What's this one? I was technically using this equation, but I didn't reference it. So if you can do it without the equation, that's fine. I'm not going to deduct marks for that. You wanted this one? Yep, we'll do the examples, and then there's practice problems from the textbook. You're talking about probability of people wearing certain clothes, right?
Yeah.
Mm.
No, we're talking about, I'm gonna be, I'm not gonna lie,
No, that was a joke. I know you weren't talking about. Yeah. Pardon me?
Can I get water? Here?
Yes. So let's try some. Because you were talking about prom. No, you were not. Your face was turning the other direction. I can come back to it once I'm done with some of these examples. Okay. So we are going to roll a die 3 times. We want to know what's the probability of these different events occurring. So let's give this a try. Probability of rolling a 5 on all 3 rolls. So if on the first roll, what's the probability of rolling a 5? If you have a normal dice. 1 out of 6. Thank you, Yassine. So that is the probability of the first one being a 5. Does the second roll depend on what the first roll is?
Yeah.
No. So every time you roll the dice, it's always 1 out of 6. So the first roll is 1 out of 6. The second roll is 1 out of 6. Pardon me?
The initial starting point of the diamond in your hand is different each time because, like, maybe you have 1, maybe you have
Yep.
3,
And the amount of spin you put on it's going to be different. There's a lot. Yep. So this is 1 out of 216. As I've said before, probability can be a fraction. You can put it as a decimal. You can put it as a percent. Anyone's fine. So leaving it like this is totally fine. If you wanted to write this out as 216. 6 times 6 times 6 gives you this. Because when you multiply fractions, you multiply the top parts.
I know. Why did you do that?
Dice have 6 times. Dice have 6 possible outcomes. Okay. This second one is a little bit tricky. So if I want at least 1 5. So we need to figure out what is the probability of rolling at least 1 5. There's multiple cases. I could have 1 5. I could have 2 5s. Or I could have all 3 5s. Go like this. Hopefully that makes sense.
Yes.
I know my 5s look like S's.
I'm doing it. Remember, it's school.
Mm-hmm.
Are you coming to our grad?
Of course.
Really? Come ask me?
Mm-hmm. Mm-hmm. I was one of the only teachers, I think, who went last year. But that was mostly because everyone was gone on holidays. Because it was in...
Teachers were traveling.
Yeah. Because normally teachers are required to go to all the grants, Even if it was not required, I'd still show up. Because I teach all the grade 12s. Yeah, it was in the middle of August, so no, barely any teachers were here. But I stayed here over the summer, so. Last year I wasn't. I went anyways. It's a requirement, but it makes sense to me. Like, for high school teachers, it makes more sense. Elementary, who don't teach you, not as much. It's different if teachers stay the full time, but I don't know. Like, I think it's good. I would come to your graduation no matter what. Should be. Okay, so let's figure out what's the probability of rolling at least 1 5. So in order to get 1 5, let's see. Let's suppose the first one is a 5. So the probability of getting the first one a 5 would be 1 out of 6. And then the other two would have to be not 5. So what's the probability of not rolling a 5? What's the probability of not rolling a 5?
Not rolling a 5?
Yeah, so rolling a 5 is 1 out of 6. What would be not rolling a 5?
5 or 6.
Yeah, 5. So I could roll a 1, 2, 3, 4, or 6. So the other two would be 5 out of 6 and 5 out of 6. Now the problem with this, and why this one gets a little bit tricky, is because this is if the first one was a 5. I could also have the possibility where the second one's a 5, but not the first. I could also have the last one as a 5 and not the first two. So because of this, I need to multiply by 3 to indicate it could be first dice, second dice, third dice. There's 3 times the probability of this. Or I could have 2 5s. So what would be the probability of having 2 5s? Well, let's suppose the first two are going to be 5. So I'd have 1 out of 6, 1 out of 6, 5 out of 6. But again, we've got a bunch of different possibilities of when the 5 could be. They could be the first two, the last two, or the two outsides. So again, I'm going to have 3 times all of this, because there's 3 different ways that could occur. And then the number of ways I could get all 5 of these, so it's just 1 out of, we calculated this one already. 1 out of 6 times 1 out of 6 times 1 out of 6. This is the same as up above. So these are our 3 cases. We could have a single 5, we could have a double 5, we could have a triple 5. So if I want the total, I'm going to take the number of ways to, or the probability of 1 5, plus the probability of 2, plus the probability of 3. So if I've got 80% of my class talking while I'm trying to teach, Yusuf, Kenzie, right now. So speaking of probability, no, shh. I've got 80% of my classes talking while I'm trying to teach.
80%?
Yeah. Elmia. No, he's not in the class. No, you're diverting the issue. So I should have Kenzie and Mariah paying attention instead of having their own conversation. I should have Yusuf and Fatima.
Concentrate. Focus.
So these are the three cases. In order to get the total probability, you add these all up. So you do all this, you would get 42.1%. So this is the tricky one when you've got multiple cases. So you'll need to take a look at this and try and figure out if in your question it says at least or at most, you're dealing with cases. Just like last unit. It's going to be the exact same. So for question C, what are going to be my cases? If I want at most 1.5, what are the cases that I've got that meet that requirement?
No 5.
Could have no 5s, yeah. So we could have 0 5s. Any other cases?
1 5.
Sorry, what's the other?
Why did we put 3 beside the first 2, but we didn't put beside the 3 5?
Because there's only one way I can get all 3 5s. It's 5, 5, 5. I can't switch those around.
I don't get.
Don't get what?
Like, I get what you say, but I don't get what you're asking now.
So does the bracket part make sense? So I said the first one's a 5.
Yeah.
The probability of rolling a 5 is 1 out of 6. You told me the probability of getting a non-5. So I've got a 5, not 5, not 5. So this is saying the total probability of rolling 1 5, that's first, would be this. I times it by 3 because I could have it first, second, or third. So 3 times this gives me the probability of having 1 5.
I know, but like to ask us, what's the probability of rolling a 5? Rolling something else, not a 5. But not one.
Because we only want 1 5.
I know, see, that's right.
So if I have 1 5, we said it's going to be first. So this is the probability of 1 5.
Why do I have to have 3 brothers? Why can't I just have that?
Because you're rolling 3 dice, or you're rolling the dice 3 times. So the second roll, I cannot have a 5, because that doesn't meet this requirement. Same thing for the last one. I have to meet this requirement, so I cannot have another 5. It helps if your mind is on track instead of all over the place. It's like, I always use this analogy. So I'm trying to guide you how to get the answer to this question. So suppose I was trying to teach you how to walk from my desk to the back of the room. And I was trying to give you instructions. And so I'm leading you along that path. But then all of a sudden you get distracted by Mr. Einstein on my wall here, on the window, and you decide to go and pay him a visit. So you go walk over there. And then you come back on the path, you listen to me for a little bit, but then you decide, oh, this tree looks nice. I also want to make sure that the paint is dry. So then you come back and you go talk over here, and then you go back and you start walking, and then you realize someone misspelled physics. Don't spend too long, it's spelled correct. But you go and walk over there and you see, okay, did they misspell it? And then you come back, and then we finally reach the back of the room. A very simple process of walking straight has now turned into a path that goes like this, like this, like this. So that's the same if I'm trying to teach you this, and in your brain you're following me for 5 seconds, then you're thinking about prom. And then you follow me for another 30 seconds, and then you're talking to your neighbor. And then you're following me for another 50 seconds, and then you're checking to see who messaged you on whatever social media you like. So if you're constantly being distracted, or by Marwan, who's standing outside my window trying to get someone's attention, if you do that, your brain is trying to jump from math to social life, to math to something else. It's really hard for you to stay focused on one thing and to fully understand it if your mind is going everywhere. That's the battle I have to face when you guys have your phones. I'm not as interesting as your phone. Never going to happen. So let's figure this out. What's the probability of rolling 0 5s? Okay, So,
0, 5.
so we're going to roll the dice 3 times.
1 out of 6,
Find
1
out.
5, because I don't want any 5s. So there's 5 options not to get a 5, 5 options not to get a 5, so on and so forth. We've already figured out what the probability of getting 1 5. Yeah. Those are the only 2 cases, 1 5 or 0 5s. And then add these up, we get 92.6%. So there is a very high probability that at most 1 5 is rolled. Any questions on this? Mm-hmm. Good.
You
I'm
want
glad.
to roll 1, 5? So you do 1 over 6, and then the rest you have 2 rows left.
And because you could either have it first, second, or third, you times it by 3.
But why does it take 0, 1, and then you have that?
Because if I want to add most, I could have 0 5s or 1 5. Whenever you're doing something or something, you add it.
I know, but why operation does 0 and operation 1?
From the fact that I want at most 1 5. So the cases where I have at most 1 5 would be either 0 or 1. At least is the one up top where you can have 1, 2, 3.
I know, I because after these, so after at least 1, 5, I get that. I think that's why there's a 1 and 2 and 3. That's why isn't it just 1, and then you put 1 over 6, and then 5 over 6, and 5 over 6, and then we get the answer.
So that would be if I want just 1 5.
Right? You can just add on.
Because I want at least 1 5 is at least 1 5. 2 5s is at least 1 5. 3 5s is also at least 1 5. Hi. No. Uh-uh.
Can you just
Yeah, I know. She's not happy about this. I know. To give it some... no, I'm not going to say that. So, is 3 5s at least 1 5? Is 2 5s at least 1? Is 1 5 at least 1? Yes, true, but I'm only rolling it 3 times. One. I've rolled it 3 times. I rolled a non-5, non-5, non-5. This is 0.
No. You're talking about the big number, not the small number. Yeah. You talk about the 1 and 2 and 3. You're not talking about the sub thingies of them.
So you're mixing up the cases with the number of times I roll it. So you're saying I have 3 different cases because I'm rolling 3 dice, correct? Is that what you're asking?
Say that at least in B, 3 rolls, so you write 1 5s, 2 5s, 3 5s. But in C, you didn't write 3.
Yeah, I didn't write 3 cases, exactly. That's what I was saying. Because
Think about this one.
it depends on what the question is asking. So if I say I want at least 2 5s. So at least 2 5s would mean no, because I'm not rolling 4 dice. I'm not rolling 4 dice. I've got 3 dice that I'm rolling. Here's my first dice, second dice, third dice. The number of cases did not depend on the dice.
Are you rolling 3 dice at the same time?
3 dice.
At the same time?
Same time. So, if...
It says a die is rolled 3 times. So one, at least one, 5 of the 3 rolls.
Okay, so let's consider this. You said with this, if I say... at least 2 5s. Okay? So 2 of these have to be a 5 at least. So I could have a 5, and a not 5. Right? That's this is 2 5s.
1 on 6, 1 on 6, and 5 on 6.
Correct. Then I could also have a 5, and a 5. This is case 1. This is case 2.
Why is it case 2?
Because this also meets the requirement. Is this at least 2 5s?
No. At least, yeah.
This one's at least 2 5s. Your argument was that then I now need to have 4 5s.
No, where's my third die?
1, 2, 3.
No, but
These are the 3 dice.
يبقى هو بيتكلم صح. فاطمة هو كده. ايه؟ لا. هو الثري رولز ده اللي هو اللي هو ما بين البراكتس. عشان كده عاملهم 3 كل واحدة فيهم. مش بيتكلم على الأرقام اللي فيها دي كيسز عادي بيعملها مع هو يا ستي انت بقى اهلك هو قال كده.
طب if I put 2 cases in B on a test on a question like this, are you gonna mark it?
For B, no. You need to meet all the requirements. This, there's only 2 cases if I say this. If I say at least 3 5s, there's only 1 case. There's only one way I can have 3 5s. That's it. There's a single case. I don't care how many dice I have. The cases do not depend on the number of dice. You're saying, this is your argument. 3 dice, 3 cases. And that's why you're confused there's not a third here, because you think there has to be 3 cases with 3 dice. The case does not depend on the dice. The case depends on my situation. So at least 3 5s, there's 1 case with those 3 dice. At most 1 5, there's 2 cases for those 3 dice.
So in B, you're right, 3 cases because it's at least to get not 5, 3 times. And here in C, you wrote 2 cases because you got the numbers you want.
If it's still not making sense, I can try and explain it to you later. But let's move on to the next one, because I've spent a fair amount of time on that. I think based on the time, I'm just going to do question 2. Question 3, if you want to do it by yourself, you can do that, but let's do this first. So, yeah, so what's that? As long as it's only 5 minutes.
Can I go with them? You gotta be back quick. I didn't think so. You're gonna be quick. You stay. Back, go back.
I'm going to wait till they come back and I'll finish off the notes. those of you watching on the video right now, you can skip ahead for, I don't know, like 5 minutes till the rest of the class comes back, and then I will continue this lesson. I'm too lazy to stop the video and then splice it together with the other one. So I'll give you a heads up when we're back.
So if I want this angle, this is my opposite side. So I'm going to use the equation a squared equals b squared plus c squared minus 2ac equals a. Opposite of b, so this is b. Opposite of c, this is c.
How do I get to that? How do I get to
No, just subtract the squares. A squared minus b squared minus c squared equals negative 2bc equals a. Divided by this number equals a equals a squared minus b squared minus c squared equals negative 2bc.
So what do you put down here?
Because that's how we put it.
So it's not, it's a point.
And then just there's
Yeah.
essentially all you need to do here is if you put it to a diagram like this, you get that.
Listen, I remember we got the skateboard with. Skateboard down here, I'm sent down. Oh my gosh.
I've had it since I first got here.
I know.
But it wasn't me, it's from Israel. Way back in 2013.
Let's say where I came here in 2013. 15?
The summer of 2013.
No, 2015. This is, do you know Egypt?
We have no plans to leave anytime soon. So, probably by the time we graduate, have kids also here.
So your kids, yeah, you think that your kids are going to be growing here in Egypt safely?
Our kids,
I love Canada.
So our kids, so our daughter, her first name is Alina. Like our name system is different. So you have first name, your last name stays the same through your generations, and then you can pick a middle name. It's not like you were, it's your name, then your dad's name, then your dad's name. It's not like that. So my last name, Cleveland, is my dad's last name, is his dad's last name, and sometimes the wife will change to the husband's last name.
Yeah,
And sometimes she keeps it.
She can't be misbragged.
Yeah, so my wife, before she was married, she was Bettina Yanta, and now she changed her last name to Bettina Cleveland.
Yes.
So the last name's changed. It's different. I guess. So anyways, we can pick the first name and we can pick a middle name. So our daughter, her first name is Alina, her second name is Noor. Yeah. And our son, his first name is Mateo, and his second name is Kareem. So Alina means bright and beautiful, Noor means light.
You know,
So bright and beautiful light. And then our son, Mateo, means gift of God, and Kareem means gift.
Yes.
So we're very much about like the names and what they mean. So our third daughter, who's due in August, will pick a first name and then she'll have a name.
You know, this means here in Egypt, asma وركة, يعني names like, you know, Ali, his name is Ali, but يعني, there is a name beside his name called B, so his name is Ali.
Yeah, so you like combine it together. Yeah, because what does Al-Din mean again?
Ali Din means Ala. Alan is hard.
Yeah.
Ala is another name. It's like
Yeah, so okay,
there
this
is
is how it is.
yeah, there is Aladdin. Aladdin.
Yeah,
In there, like,
It's not like a religion.
yeah, it's a religion.
So like a religious term.
Yeah, it's a religion. And Alilad, I think, like, بيتقال في إسرائيل. Yeah.
Like higher respected or
Yes.
like esteemed kind of.
Yeah. So Ali means high, like high. So his name more cool.
Yeah.
Good. My name is Nigger. Yeah, I don't know why 75% of teachers here in this school say Nigger. Yusuf and Nigger. Why? I don't know. My name is Yusuf and Naggar. Naggar,
I don't know.
Carpenter.
It has an
It's
English in it.
Naggar means carpenter in English. You know carpenter? Naggar. Everyone here, nigger. Yusuf and nigger.
There is no, yeah. I don't get how they get that out of your name. Because how do you spell it?
N-A-G-R.
A and an A.
Yeah.
There's not, as opposed to an I and an E.
No.
I don't know what it
Miss Nicole, the good drive, she shared me a folder. The folder names N-Nigger. N-Nigger.
You know what? I wonder if it autocorrects. Although that would be terrible if it autocorrects.
I don't know why. Miss, I don't know. The miss that came, that have a sister here, and she left this year. She was here last year, and she was and gave us the classes in Miss Corina's room. She was like, I don't want to say something bad, but she was. I don't mean anything wrong.
Oh, yeah, so not. I know who you're talking about.
Yeah, she called me a nigger, and she's very happy with me saying it's my name. Yeah. That's my word. Here in Egypt.
I know. Some names I just like, I always mispronounce, so I always ask before and not pronounce it.
But you are here from like 9 years. So I think you know some Arabic words.
I know something. I can pick up around.
Yeah, I think you can know whereas people have an Arabic. You can. I know the general information about this. I think like Miss Lisa.
What helps is the fact that you guys often put in English words into the topic. So I can pick up the conversation based on the English words, and I get the context, and then from there I can understand the Arabic.
Yeah, Miss Lisa knows Arabic very well. Like the first day I took with Miss Lisa, I was just speaking Arabic. I was just joking. I told her she gave me she took me out. You were coming back.
Yeah, I haven't finished my lesson yet.
So you have to go to 210, to whatever? Okay. Okay.
She kicked me out, so I told again. I said, "I'm waiting for you outside," but in Arabic. Yeah, I was just joking. I said in Arabic. I found like she's angry, and she came running. What did you say? I'm sorry. I'm sorry. I was just joking.
I mean, you can pick up a lot of language just by body language and the tone. So, I remember in my first few years, like, kicking someone out, and then as they're walking out, they say something, but it's the way they say something, you know, they're saying something like that.
I know. I was laughing, but she understand what I said. She understand what I said. She was so mad. Yeah. Oh, there's someone from my class said what did I say in English?
No, who else is missing?
Fatima and Kenzie was going to the bathroom.
Actually, you want to get her to the same.
Yeah. That's it, yeah.
Okay. So, start with open.
Okay.
Okay. And Jason 205, Jason 205.
Okay, so I'll teach you really slow.
You want to do 2:30?
2:30, sure. Go into our pro D evening, all of that.
I'm based solely on how.
Mister, I will leave early. I will leave early.
What's that?
I'm not gonna go past.
You know, one thing that doesn't make sense about your cap and gowns is you guys spent a fair amount of money for these, right? And you use it for pictures and ceremony. And then you think, well, some people are like, oh, I'm going to use it again and it'll be fun. No one ever uses it afterwards. Yeah, what, like, you can make a lot of, how many of you are going into business? Thinking of going into business? So you can make a fair amount of money. All you do is buy all the gowns from the people who don't want it, 500 pounds, buy them all for 500 pounds, sell them to next year's grads, 800 pounds.
Mister, I can do something like this and I pay 500 pounds.
Yep.
500 pounds, 600 pounds. From this.
You just need cardboard.
We pay 3,000. But I can't.
Is it 3,000?
Yes.
Really?
Just for 3,000.
Oh, you can upsell that. Buy them for like, you could buy them for 1,000, sell them for 1,500.
Something like this exactly. 300 pound, 500 pound maximum.
Doesn't make sense. When I graduated from high school, we rented the gowns.
Yes.
You rent it for like $20. So I don't know what that is in pounds, but it's like a couple hundred pounds.
I think you like business, so.
Ish. I can do some business stuff, but it doesn't make sense.
I'm trying now to learn about business.
To think about it.
Yeah, no, I don't study business marketing, business marketing and business administration.
Yeah.
So I know, yeah, I like this college, but I'm trying to work with my dad also in order to understand what I'm going to be in.
It's a different mindset. It completely is. It's not just a learn. It's lots of experience in being able to
Yes,
think
of course.
like that.
My dad, because he was working in business for a long time, I learned from him a lot of things, business, like buildings and how can I buy and how can I sell.
Yep.
I understand from him a lot.
Yep. Makes sense. Okay. So let's continue on with question number 2. So suppose we are going to take one bill. So these are different bills that are going to be in your 2 different containers. I'm teaching right now. Yep. So in pot 1, I've got a $0 bill. No idea what that is. 10, 20. And in pot 2, I've got a 0, 2 10s, and a 20. So we want to know if I do this, one bill is randomly selected from pot 1. So I take one from here, and I take one from here. What's the probability of getting a 10 on both picks? So is this dependent or is this independent? So if I'm taking one from here and if I'm taking one from here, does taking a $10 bill from this one depend on what I did here? No, because these are 2 separate things. So this is going to be independent. So if I want to figure out the probability first, let's figure out what's the probability of picking a 10 from the first pot. 1 out of 3. Okay, so for the first pot, we got 1 out of 3. What's the probability of picking a 10? Try again. 2 out of 4. So calculate this. Got 2 out of 12 or 1 out of 6. I will accept both. Doesn't matter. So this would be the probability of doing that. Now let's figure out what's the probability of getting one $10 bill from either one. So in this case, I've got two cases. I could either get $10 from pot 1, or I could get $10 from pot 2. I've got two cases. Either it's this or it's this. So let's figure out what's the probability first of getting $10 in pot 1 and not $10 in the second pot.
So it would be we're going to something both of them.
So yeah, so what's the probability of getting a 10 here again? 1 out of 3. And what's the probability of not getting a 10?
4 out of 4.
Because 2 of those are 10s.
So
2 out of 4. Here and here.
go to take that.
I don't want 10. I took a 10 from here. And I only want one 10. So this one is 2 out of 4. So that's the first case. $10 in pot 1 and a non-10 in the other one. Plus, I need to add the second case. So if I'm getting a $10 bill in pot 2, I do not want a $10 bill here.
So 1 out of 3. 3 out of 3. 2 out of 3.
That's the last option, so yes. Because this is not a 10, this is not a 10. Her gown is even on her desk. So this one's a little bit is tricky to understand because there's two 10s that you can pick from and two non-10s. But this is what you get for the other one. So this is getting a non-10, this is getting a 10. Times them, add them. It's actually going to be 50%. Believe it or not.
Easy.
It's not too bad. I wish I could just stand under the AC. I said I wasn't going to do the last one, but this one's a little tricky, and I do still want to show you. Do I want to show you that? Yes, I do, because you're going to get questions like it on the practice problems and from the test, so I think it's worth it. So now suppose, instead of picking one bill from both pots, I'm going to first randomly pick a pot and then pull out a bill. So I'm going to close my eyes. I'll pick one of the pots. So let's say I pick this one. So I pick pot 2, and then I'm going to take out a bill. So does the probability of the bill depend on which pot I pick? Mm-hmm. So think about the $10 bills. Does my probability of picking a 10 depend on if I pick pot 1 or pot 2?
No,
Well, does it depend? Yeah, it does, right? Because here, my probability is 1 out of 3. Here, my probability is 2 out of 4. So if I pick, depending on which pot I pick, my probability changes. It's dependent on which pot I pick. So this case is going to be dependent. So let's try this. What's the probability that a $10 bill is chosen? Well, let's think about this. I got two cases.
So it will be dependent. So we're going to pick only one cell for both two. To be dependent.
Yes. So, in figuring this out, let's think of this. I could have, let's say I pick. So with this, I could have two cases. I pick pot 1 and a $10 bill. Oops. This could be the first case. Or I could have pot 2 and a $10 bill. Why did I write it out this way? I'm going to show you how to make the equation simply from this statement. Because once I've got this, it's pretty straightforward. So probability. What is the probability of picking pot 1?
1 out of 3.
There's 2 pots. Pot 1, pot 2. The probability of picking pot 1, 1 out of 2. What is the probability of picking a $10 bill from pot 1?
So it would be 1 out of 3.
Now you got it. 1 out of 3 for picking the $10 bill. What's the probability of picking pot 2?
Pot 2 would be 2 out of 4. 2 out of
2 pots, 1 out of 2 that I'm picking from. What's the probability of picking a $10 bill from pot 2? Yeah. So I did it like this because I want to show the relationship between ands and ors. So if I want pot 1 and $10, you're going to times. So same here, pot 2 and $10, so the and means times. If I want this case or this case, I'm going to add. So this is pulling from last unit, timesing, and ors are plus. And then you're going to calculate this. So try this out, and you get 41.7%. I'm going to stop there. I'm not going to do the last one. The wording on the last one is really tricky to figure that out, so I'm going to stick with this. I'm almost done. Then yes. So the practice problems are here. 5.1 and this one, 5.6, are the only two that have practice problems from the textbook. So make sure you're working on that. The other 4 sections in the middle have a worksheet that's in the booklet. What was the other thing? Oh, your mid-chapter quiz for chapter 5. Yusuf, got the math? So your mid-chapter quiz, I posted the questions up on Google Classroom because I forgot to do that. It's due the day before the test. So your test is Tuesday, or you guys are group 2, Wednesday, May 26th. So on Monday, May 24th, the mid-chapter quiz is due. So make sure you have that done by then. That is your set of notes.